in the instruction that was given, we were given 5.5 grams of anhydrous FeSO4. And if you use the 5.5 grams of anhydrous FeSO4 to calculate the number of moles of the anhydrous FeSO4, you will get 0.0362 mole. Why? Because that will be 5.5 over the molar mass of the iron 2 sulfate, anhydrous iron 2 sulfate, which is about that should be about 152. Yes, that should be about 152. That is 0.0362 moles, which means that if you dissolve this amount of if you dissolve this mass of iron 2 sulfate in 1 dm cube of water, 5.5 grams of iron 2 sulfate in 1 dm cube of water will give us what? 0.0362 mole per dm cube of iron 3 sulfate in water, right? All right. Now, but we don't have this. This guy is very scarce in the market, yes, and there's nothing you can do about it. But we have the hydrated form, FeSO4.7H2O. This is a titration. This is a titration experiment, and titration has to do with the quantity of a substance present in a solution, right? Now, since you're titrating, since this is the active ingredient in that substance, in that solution, it means that this water crystallization will just be what? Will just be a form of impurity, right? So it will not, this water crystallization will not partake in that titration reaction or redox reaction. So then what mass of this guy, what mass of this hydrated salt can we measure, right? What mass of this hydrated salt can we measure and dissolve in 1 dm cube of water that will still give us this concentration, this same concentration as anhydrous iron 2 sulfate? Very easy. Now, this is the concentration you want to achieve, right? That's 0.0362 moles per dm cube based on the instruction that was given. So what do we do? What is the molar mass of this? The molar mass of the hydrated salt is 278. That's 152 plus 7 times what? 18. That should give you what? 278. Now, what we are looking for is the what? Is the mass concentration. What we're looking for is the mass concentration. So what do we do? So mass concentration or concentration in moles per dm cube, or mass per dm is also what? Molar concentration times molar mass. Right? So what is the mass concentration here? The mass concentration here, the molar concentration is 0.0362, right? Where the molar mass is what? 278. So if you multiply this by 278, that should give you a what? 10.06 what? Grams. Simple. So that's how we obtain our 10.06 grams for the hydrated iron 2 sulfate, which will later dissolve in water to get our iron 2 sulfate solution. All right. So now that we know how to calculate that, this, let's now go into the live practical session. Please drop your comment. If you have any question, drop it in the comment and we'll attend to it. So now, first off, I already prepared my my potassium permanganate KMNO4 by dissolving 1.58 grams of this in 1 TM cube. I had used it before. That's why it has reduced, right? So I don't need to prepare this again because I want it to diffuse completely, right? Good. Then ion 3, the ion 2 sulfate solution, I need to prepare a fresh one, which is what I'm about doing now. Then, before I do that, this is my concentrated H2SO4, and I just prepared it not quite long, and I did that by dissolving 5 mils of 5 cm cube of concentrated H2SO4 of 98% purity in 100 mils of water. So you can see this is my 1 molar H2SO4. Okay, so let me weigh I'm going to weigh my what do you call it, salt now. Okay, since I'm just working with the little quantities, that's 250 mils, I'm going to weigh 0.395 grams. I'm going to dissolve 0.395 grams of the salt in 250 cm cube of water. So I need to zeroize this. Fine. So I'm now going to add my salt. I have to be fast because this guy does not waste time getting oxidized. That's already too much. All right, I think I've obtained what I want. Good. So next thing is to dissolve add a little amount of distilled water. Stir. Let me close this well to prevent further oxidation. So it ought to dissolve, yes. Okay. Next thing is to turn it into my volumetric flask. I have to be fast. I'm done with my, so I put this away. Volumetric flask, 250 mils. Okay. I rinse it. Okay. Add more water, make it to the 250 cm cube mark. Looking, watching my lower meniscus. Almost there. Okay, so having done with that. I shake it, you can see it's almost brown. That is iron 2 almost. That will be freshly prepared. Good. So having done that, the next thing is to take 25 cm cube of it. But before I do that, I would like to fill my burette. Yeah, I like to fill my burette with So immediately I'm done by pipetting my iron 2 solution. I'll start my titration. Okay. I need to adjust this. I want to start from 1 because, yeah, that's more like it. I have to have removed that funnel before adjusting. So don't do that. Well, I'm fine. So with this now, I can then pipette my FeSO4 solution, because it's already turning brown. So just follow us step by step. Like I told you in the afternoon, whatever you get at your timeline does not matter. What matters most are your steps and your consistency, the consistency in your values. Okay. Let me see. Okay. All right. So all right. So while that is filling emptying out, let me quickly measure my 10 mil of my acid. acidify the solution, the FeSO4 solution, to prevent it from oxidizing to Fe3 plus. If you like, I make it 10 cm cube or 20 cm cube, anyone. Okay. So with this done, all right, so I now pour this into the mixture and then into the solution, sorry, and then titrate. I now carry out my titration. So I bring this close. I bring my retort stand close. So I will adjust this to ensure, yes, the tip gets directly into the conical, inside the mask, inside the flask, sorry. So my initial reading here, hope you have seen that, is 0.0. I'm going to carry out this just once, to just let you have an idea. My final reading, then my volume of B used. Okay. So this is my burette readings in cm3. All right. So volume of B used in cm3. So let's go. Let's see what we will get. All right. So I want to take this slowly. Sorry, my initial reading is not 0.00, it's 1.00. Okay. So be careful. There's no harm in adding it in drops since you're just starting. Sorry, yeah. What's this? I got 3 point something. It means my iron 2 has seriously oxidized. Yeah, Mr. Obire, you say, I ask whether I'm using anhydrous or hydrated. I'm using hydrated. Mr. Joseph Ogbonna said 0.0362 molar is for anhydrous. Yes, whether anhydrous or hydrated, since you are not using the same mass, since you're not using the same mass, 5.5 grams of anhydrous in 1 dm cube of water and 10.06 grams of hydrated in 1 dm cube of water will give you the same concentration of 0.0362 molar or moles per dm cube. I'm very sure there's something wrong with my measurement. there's something wrong with my measuring, because when I did this in the afternoon, I got 15 point something, minimum of 15 point something, 15.5 cm cube. Yeah, so I don't see why it should be giving me different results now. I don't see why it should be giving me a different result now. I'm very sure I didn't measure up to the expected mass of my hydrated salt. Okay, so let's run this again quickly. Let me quickly get at 7.31. Please, your 1 as initial reading, explain. Now, why do I use 1? I couldn't use 0 because the what do you call it? The KMNO4 is not colorless, so I may not be able to see the 0 mark. That's why I chose 1. At least I had to bring it down to where I can see the reading, the graduation. That's why I chose 1. If you are sure that you can get the 0 mark correctly, you can go with it. Then Promise or Diakwa says, please, do ferrous sulfate come in anhydrous? Yes, it can come in anhydrous form or hydrated. But the challenge right now is that most of the anhydrous iron 2 sulfate is scarce in the market right now. So what you have most is the hydrated form, and you have to work with that. There are no two ways about it. So that's why I took time to explain how to obtain the actual mass to dissolve in it. Yes, people have tried it and they've got the expected result, right? Actually, the theoretical titer value should be 18 point something, right? And given the nature of iron 2 sulfate, it's easy oxidation to iron 3. So if you are very, very careful, you get around that 18. But if there are some errors which are marginal, you can get from 15 to 20, which is still okay. Like I said earlier, nobody will penalize you on your titer value, provided you are sure that what you did is you follow the correct steps. There is no fixed titer value. There is no fixed titer value for any in the marking scheme for any practical, right? Yes, because everybody is not using the same grade of chemicals. You all use different grades of chemicals, so you cannot expect my titer value to be the same as yours. Okay, so having said that, let's see, because I was suspecting that something was wrong without my reading. Okay, .4. Oh my word, the mistake is mine. I made a mistake somewhere. I was using the mass of KMnO4 for iron 2 sulfate. Oh my God. Actually, I meant to dissolve 2.52 grams in 250 cm3. Please take note of that. It's not 0.395 that I dissolved in there. It's meant to be 2.52 in 250. I was actually using the mass of concentration of KMnO4. Ignore my, 2.52. Because I was wondering. Okay, I think that's okay. So yes, this looks more reasonable. Try and get the anhydrous solid. It's not about trying to get the anhydrous solid. If you cannot get the anhydrous solid, so you should have, yes, thank you, Mr. Obiri. I should have weighed 2.5. Yes, thank you. I just realized that. Thank you. God bless you for always being there for me, Mr. Obiri. Please, yes. It's 2.52, not 2.25. It's 2.5 because 5.03 is in 500 cm3. So 2.52 will be in 250 cm3. Yes. Thank you very much, my people. You guys are wonderful. Because I was wondering what happened. I'll just have to start from here. Promise. Thank you very much. Appreciate you guys. At times these chemicals, they can just mess you up when you least expect. I was wondering, this is the same thing I did in the afternoon, and I got the results. So what's happening now? One of those things that happen. I don't want to waste much of our time, so let's be fast. Let me get more water, more distilled water. I'll be right back. Please don't use your tap water for your titrations. Always endeavor to use your distilled water. You can't buy it in the market. You can always collect it from your ACs. The ionized water. It's still the same thing, right? Okay, we are there. Good. So you have to shake this to ensure that it mixes properly. Okay, let's leave it there. Now let's clear this. All right. So where's my volumetric, my pipette? and my pipette filler. Wachuku Christopher, I see you, I cite you. Thank you. So let's go again. You know, science is all about trials, tests. I have not acidified yet. It's when I want to start the titration that will acidify. Let me pick this up to see. Yeah. Okay. Let me cover this. Always cover your iron 3 immediately. Iron 2 solution, sorry. Okay, so I get my acid. This where I'll carry out the acidification. Okay. That's my funnel. Okay. I rinse. If you are a student, please keep a date with us. God willing, we'll be having a live session before your chemistry theory, where you'll be free to ask questions on any topic that bothers you. That's 2, 4, 1, 2, 3, 4, 5, 6, 7. Okay. All right. Still. All right. So I pour this as acidification. It is very, very necessary. Yes, this way to acidify the FeSO4. So I now come here. What's my initial reading here? My initial reading is 3.3. 3.3. So I'm going to bring this down. Bring it here. Initial reading is 3.3. So let's change this. 3.30. So let's go. Make sure I put it this way so that I can see what's going on. All right. So let's go. Your eye should always be on the conical flask. I'm watching my conical flask until I get a permanent pink color. You can keep on leaving your comments, what you think about the practical so far. Yes, Nekachikwe acidified the the FeSO4. Wachuku Christopher, yes, acidified the FeSO4. It's very, very important. And make sure that your, your KMNO4 drops directly inside and not on the walls of the conical flask. Let me respond to some questions. So I can't find FeSO4. The store only, yes, I addressed that earlier. The store only stores have hydrated FeSO4. So you can also use hydrated FeSO4. That's what we are currently using. So let's see what we get. I had tried this earlier in the afternoon and I got 15 point something cm3, which is still close to the theoretical value of 18.1 cm3. So let's continue. At least with this, you can get the result here. You'll be convinced that the hydrated salt can also give, but there's a mass that you must use. The mass that we cannot use the same mass as in the anhydrous. Anhydrous, you have to use 5.5 grams, but in in the hydrated, for the hydrated, you use 10.006 grams. I explained that earlier. Please can share the link to others, to your contacts, so they can also join. You can join the session. Actually, I want to be careful. I want to be accurate. That's why I'm adding them in drops. And adding the KMNO4 in drops. Can I sit down? This is not allowed. promise. Okay, you're welcome. So let's continue adding. You have to be very, very patient if you're adding in drops. So you don't overshoot the titer value. If you add in drops and you get your result, you don't need to repeat it. You can just extrapolate the remaining values with the difference of plus or minus 0.1. Please permit me to sit down. My waist. Okay, though it's not allowed in the lab, but this is obstructing me. I need to turn it this way. Yeah, permit me. Yeah, it's not allowing me to shake this well. Thank you, sir. Thank you, Wachuku Christopher. Thank you for your recommendations. Yeah, I prefer it this way. Okay, let's go. Yeah, we are there. We are there. Yes, we are there. Can we see? And what is my titer my volume here? My volume is 17 point. Is about 17. Remember, you take the upper meniscus. You take the upper meniscus, not the lower meniscus. This 17. Yes. So, yeah, this is my initial. My initial was 3.30. My final is 17.00. So my value here is what? The volume. My volume use is what? I'll be 16. 30.70. That is my value. If I were to write this exam, this is the value I will work with. I don't care what any other person gets. This is what I would work with because I am sure of my procedure. I'm sure of my steps. So my next values would be either I'll work with either 13.7, 13.8, 13.7, or 13.70, 13.80, 13.80, whatever. But at least you can see that with the hydrated, you can get something close, or if not exact, to the range of the theoretical word value. So you can use your hydrated. Yes, love it. You got 16.8. That is possible, very, very possible. Earlier I got 15.5. You know, iron 2 oxidizes easily. So if you waste too much time on expose it for so long, it will keep on oxidizing to iron 3, and the concentrations of the iron 2 ions will keep decreasing in the solution. So that's that. So that is your titer value, or that's how to get your titer value in this titration. at least we have been able to put this to rest now, that you can use the hydrated iron 2 sulfate for your titration. Let me repeat it. If you are to use the hydrated iron 2 sulfate, yes, it's already here. Hydrated, you use 10.06 grams. You dissolve 10.06 grams in 1 dm cube of water. If you are using an hydrous, which is scarce in the market, you dissolve 5.5 grams in 1 dm cube of water. And of course, remember the mole ratio. The mole ratio of the KMnO4 to the iron 2 is what? 1:5. That's plus 8 hydrogen ions, giving us what? Mn2 plus F5Fe 3 plus 4 H2O. So ratio is 1 to what? 5. So you can use your CAVA equals to NA over NB. CAV over CBV equals to NA over NB to do your calculations. You can watch our videos on past volumetric analysis calculations. It's the same thing, it's the same pattern, right? So just watch those videos and learn more calculations on it. Thank you very much for joining. Thank you for your comments. I can see you, His Majesty channel. I can see. Thank you, Mr. Obire Onome Williams. I appreciate you. Owatuku Christopher, I appreciate you. Please, sir, how can I chat you up? Okay, you can chat me on my WhatsApp 070. Okay, let me clean my table. I'm done with this. Thank you. 070-3477-6117. So this is our WhatsApp line. Yes, that's our WhatsApp line. So feel free to send me your comments. Thank you, Lovett. Yes, theoretically it is 18.0, 18.1. You are correct. Theoretically, yes. The theoretical value is just to serve as a guide, right? Like I said earlier, stick to your titer value. Just be careful, like what I've done here, adding drops until you get your value. Be accurate in your measurement, be accurate when weighing your mass, when measuring the volume of your solutions. Just be accurate enough. Then adding drops until you get the first permanent change, pink color, and you stop. That is all you need, and then you work with that. How to acidify the FeSO4? Yes, you just use 1 molar concentrated, 1 molar H2SO4. You measure 10 mils of it and add to the 25 cm cube of the FeSO4. How will you prepare 1 molar? How will you prepare 1 molar of FeSO4? You can do that by dissolving. You can dissolve 49.5 mils of the acid in 1 dm cube, right? But you don't need up to this. You will only end up wasting the acid. So what can you do? You can just do 4.95 mils. That's almost 5 mils in 100 cm cube, which is what I did here. So by so doing, you will get your 1 molar. This will give you your 1 molar H2SO4. So after pipetting your iron 2 sulfate, you use your measuring cylinder, you measure 10 cm cube and add to it. If you like, you can add 20 cm cube. Doesn't really change anything. The most important thing is acidifying the solution to prevent the further oxidation of iron 2 to iron 3 before you start titrating. So, thank you very much. Thank you all for joining. God bless you. We appreciate you. So this is where we are going to stop. If you are a student, stay tuned to our next live session on where we'll be treating or answering questions on the related to the essay chemistry, WAEC chemistry. So come with your questions, and God helping us will be there to answer them. Thank you very much. What you could, sir, please, you are, oh, sorry, sir. Sorry. Maybe I should bring it closer. So if you are yet to subscribe, please subscribe to our channel and follow us on our social media platforms, right? For more information. So what you do, Christopher, are you okay now? Are we good to go now? All right, so until we come your way next time, I remain the Science Chef. God bless you, stay safe, and see you next time. This doesn't want to end though. Am I teaching physics? No, but I have a physics teacher. I have a physics guru that can. I have a guru in physics, yes. I have a team of teachers that handle different subjects, from English to the sciences. You are covered. All right. Hello, Dana. Okay. So, okay. All right, see you guys. So what about the SWOT? SWOT analysis is already there now. We have uploaded the SWOT analysis. We have uploaded the SWOT analysis. Send, you have my number. Send me a chat on WhatsApp. You have my number on the screen there, on the board, 07034776117. So send me a message on WhatsApp. I will send you the link to the SWOT analysis. Love it. My number is on the board. 07034776117. Right? You are interested in physics. Okay. Then chat me up. Chat me up. So that will be all for today. God bless you guys.